Hello friends, welcome to my one more new videos. In this video, I'm going to discuss about the preliminary design of column. Preliminary design of column. What we should have to do first. Here is an architecture drawing. There is a lots of column in this drawing. We have to select those column which offer the more load. It's considered area occupy the large area where the more load was applied to the any column. If you select this column, there is only the load on this column is half of this and half of this. That is only this much portions is the load has taken in this column. So you have to select. If you select this one, then this column, this column, this column, and this column. That is half, half, and half. Only this much you have to select those column which was offering the more area, cover the more area that all the load was transferred to that column. I am selecting in this case in this article drawing we are going to selecting this column. This column select the large area, even though you are dividing this into half and this into half and this into half. That is this this column cover the this this much area, that is the large portion of area, that is G8 column. Okay, and our column is axial load on the a preliminary design of column, that is column G8, where designing the preliminary design is axial compression load criteria. Here this is our selected column. In this column, this column is our this column. Okay, and there is the next in the left, there is the next column, there is next column, there is next column, and there is next column. The distance between them is 3.755 meter and 3.5 meter overall column to column distance, center to center, and this column to this column center distance, and column to column center distance, and this column to column center distance. That is, it is divided into the half portion because this much area this much loaded area are taken in this column. Okay, you have already calculated. You have to calculate from the AutoCAD, and for the calculating of area of column, there is the PU, that is design load, total design load are constituted applied to this column, that is PU is equal to 0.4 FCK AG minus AG means gross area minus percentage of steel into gross area by 100 plus 0.67 into FY plus PS percentage of steel into gross area by 100. PS is the percentage of gross area, so dividing by 100. And here we take the grade of concrete, it is FCK is FE 500, and grade of steel FY is M25, that is 5.25 MPa. And assuming the percentage of column for designing of column, we should have to be assumed the percentage of steel is 0.8% to 4%. Here I am going to assume the 2%. And load calculation. Load intensity on slab. Okay, total area of slab I have calculated 14.2416, that is area covered on this much. If this is your column, there is next column, there is next column, there is next column, then how much it is much area covered. So you have to be calculated this area is equal to, that is total length into breadth. Simply we have calculated total length into breadth. We have calculated length into breadth. Okay, that is length or breadth is there. I have calculated this is our length, and breadth, that is 7.5, 7.22 and 5.22. Okay, put something in there. And overall depth of the slab is 150. I have already calculated the slab. And the self weight is 3.75 according to IS 450. According to IS 875 part second. And imposed live load is 3 kilonewton per meter square, floor clearance 1 kilonewton per, assuming a total intensity is summation of this self weight plus live load plus floor finish load and the load on the slab. This is in meter per kilonewton per meter square and multiply with area. This load into area and load of wall. Take 30% opening, then load of wall is equal to wall for take 30% opening, then left is 0.7% into 19.6, that is gamma of brick wall, into 0.11 is the thickness of wall 110 mm, and m25 m20 that is height of the floor, into, you should have to multiply, then multiply the sum of the wall of the column side by side. In our case there is only the wall on the two side and the two side is open, so I am selecting adding this and this only. If the column in between the four wall joining with the 4 1, then you should have to add the 4 side half, okay? Where I am only adding this much, 2 only, because in this case there is only two wall in two sides. And the load of beam similarly we have to calculate 25 into area of the beam, cross section area, that is B. I have already calculated in the beam case, B into D depth, that is depth, the overall depth minus slab, slab depth is, that is depth of beam, into beam length, that is on the four side half in the column, four side half this half only you should have to add, okay? Then you have got the load of beam, and again dead load of the column. Dead load of column is column, but column is made up of concrete, so 25 into, I'm here assuming the size of column is 500 by 500, so 25 into 500 into 500 into height of column, that is height of floor, that is where you get the dead load of column. And total load of column is equal to slab, wall, beam and column. Overall total load is, here how much floor you have. There I have 13 floors, so I multiply with the 13. If you have the floor 5 floor, 10 floor, then you have to select to multiply with the 10th floor, okay? And then adding 15 to 25 to 30% for earthquake resistance, okay? And the total load, here I am adding 25%, so 1.25 times the total overall total load, and factorial load is equal to 1.5 times these loads, and then you calculate taking 2.5%. Here I am taking 2.5% steel and M25 grade and AP 500, and P is 0.4 FCK AC plus 0.67 FY area, that is AC on area of concrete, and AC is the area of steel. Area of concrete is equal to cross area minus steel, percentage of steel, that is percentage of steel into gross area. Steel area is equal to percentage of steel into gross area, okay? And you have using this formula, you have calculated this AG. How I am solving these equations? Here I have forming these equations in the equations value, that is 0.46 into FCK, that is 25. FCK, that is 25 into into gross area AG, that is AG. Here you have not selected anything, you have selected here 0. Okay, here you have select nothing, you have to select only select these gross area portions. If there is nothing in calculation, in the calculation times there is nothing. Okay, there is nothing. Okay, this times there you have to go the equation, make the equations. 0.25 into f secret 25 we have already selected. Okay, and then the gross area this selecting and minus 0.025 here, that is PS percentage 2.5%, so 0.025 into AG, that is these portions, plus 0.67 into FY is 500 into PS1, PS is 0.02, 0.02, that is 2.5% into this portion you have select and press enter. Getting your value is here 0 because there is no value, and this value the right side value PU, that is PU, I have PU 1000 10,371.01 kilonewtons. So you have to multiply this and put there. I'm using this into 1000. Okay, and then I have got this much value. Okay, 10,371 0.003. Okay, this much value I have got. And then you have to go from the data, what is function on, and whole sheet. We have selecting the equations value here and take the value here, that is 1037.1006.3, and the cell you have to change, that is this one, and press OK. Then you have got this value. Okay, you have press OK, and you have got gross area is, that is 57 5,72,193.5, and B into D is equal to this, that is area, and B is equal to root under this. We have got 756, and D is equal to this, and where I am assuming the size of column, adopting the size of column, adopting size of column is greater than this, that is 800 by 800. Okay, here we have got that is the preliminary size of column 800 by 800 mm. In the slab portions, in the slab portions, in the last video disconnected, so I am going to again discuss about the slab portion. You have to select the slab. You have to select the slab in a figure. In a slab, you have to select the larger big slab, and the slab that is the shorter span 19 feet 9 inch, and so longer span 24.8, and you have to calculate Ly by Lx, and if Ly by Lx is less than 2, then 2 greater than 2, that is 1 way, and less than 2, that is 2a slab, and get concrete 500 and CSK 5, and assuming percentage of C, that is 0.12% to 1.2%, I am using 0.4%. From IS 4564 code, alpha beta continuous slab for 26, beta is equal to 1 because the span is less than 10 meter, and gamma is equal to 1.13 from the FS 0.58 into 0.58 into FY is equal to FS, and the percentage that is still using this in the figure 4. You have got 1.13 and 11 assume, and percent for I equal D by Lx is greater than 1 by alpha beta plus gamma delta, and this you have to calculate the D, and D is greater than this, you have to add 10 210, and 210 is the effective depth, and overall depth is equal to effective depth plus clear cover 15 mm plus diameter of bar by 230. And again we calculate from the moment criteria the dead load of the slab, that is 25 into D capital D dead load, and 12 mm thickness of the slab on the ceiling of plastering, that is plastering for 19 to 20.4 with gamma and 12 mm thickness. We have calculated for the marble 26 into 12, that is D20, and 26 is gamma, and portion 1 and total load is equal to summation, and live load is 3 according to the residential building, and the total load is 10.30 6.8, that is dead load and live load. Ultimate load is 1.5 times this, and calculating the IS code table number 26. We have got 26 page number 91, the IS code 456 2000. Here you get alpha x and alpha y for the uh, maximum radial movement of the interior panel. Okay, and the x movement in the x directions and y directions, and that is m alpha x w by l x square and alpha y w by l x square. And you have to calculate this one using this formula, and you have to calculate again this and using this formula, and you have to calculate the d. Here p is equal to m is equal to 0.133 FCKP into dA square, and b is equal to 1000, FCK is equal to 25, m is equal to the greater value among these, that is 36. And we have to calculate the d, small d. We have calculated this using this formula, and d we have got, and capital T is equal to overall effective depth, d is 110, and overall depth is equal to 113 plus effective plus clear cover plus diameter by 2 capital. And among the deflection criteria and moment criteria, which one is the greater value we have selected among them. Okay, and here if the effective depth is greater than 115, that is 210, so there need to be secondary beam. For the secondary beam you have to be again this process continue for the secondary beam. Here the larger, which one is the larger span, that is 24.8, that is 4.8 24.8 inch was divided by 2, that is a smaller span, that is going to be a smaller span, and the largest span is going to be 19 feet 9 inch, 19.9 feet and 12.2 inch converted into the mm. And again we have got the ly by lf, that is less than 2, that is 2 slab, and grade concrete 500, and FCK 25 percentage of reaction 0.1 to 1%, 0.4% alpha beta gamma alpha for 26 for the continuous slab, and beta is less, span is less than 10 meters, so 1 gamma is equal to 1.13. We could do that percentage of 4%, and gamma is equal to this from this criteria from the 4, and that is 4.69, and lambda is equal to W1 into 1 for the slab. And using this formula we have to calculate the d, and d we have got the greater value of the 130 plus 100 and the effective date, and overall depth is equal to effective depth plus clear cover plus diameter of bar by 2, and moment criteria self weight is equal to b 25 into d, and 20.4 into 12 thickness, and 26.2 mm thickness, and 1, and that is summation of this load, and live load is 3, and total load is equal to 8.306, that is summation of dead load plus live load, and 1.5 times total load. Alpha beta calculate from the 25 for the maximum moment. mu is alpha x is omega l x square, mu is equal to alpha y, and also here you have calculated the moment, you have got the two moment, and there is two moment using this formula. You have to calculate the small t, here the p is 1000 mm, and fck 25, m is greater among this, and we have to calculate the d, and d is equal to 58.60, but according to the Indian standard, the minimum depth of the slab is less or greater or equal to 100 mm minimum. Minimum 100 mm. So you will say I will take the 100 mm. The depth of slab should not be less than 100 mm. So I am taking the 100 mm according to the NBC. NBC depth will be greater than 125 mm. But here I am going to design from the IS Indian standard, so I have taken the 100 mm, and 100 mm plus capital D is equal to 100 mm plus 15 mm clear cover plus diameter of bar by 2, and result is 120, and you have to select among the both criteria, the movement criteria and deflection criteria. Which one is greater? Then you have to click the depth. It is the effective depth of the slab. It is the effective depth of the slab and overall depth of the slab. Thank you. Thank you for watching this my video. I think I'm providing you what information you have to be get. Here I'm going to provide the preliminary designs of all the slab beam column. I think you have to you have to understand this. This will be easily for your work. Thank you for watching this video.